Lysergic acid diethylamide, commonly known as LSD, is commonly used as a recreational drug that induces psychological effects, and users have reported seeing a variety of colored patterns, ripples on objects and surfaces, and other disconnections from reality such as out-of-body experiences. LSD is an ergoline derivative that comes from the ergot fungus. However, ergot does not look like a mushroom. It actually looks a little more like this. LSD can have up to 4 different configurations. All the properties associated with the psychedelic drug, however, belong only to the plus D-LSD isomer of the drug, which is also known as the absolute configuration of LSD. The two isomers, or different configurations, on the right are non-existent in nature but are theoretically possible. The left two isomers are in constant equilibrium in a basic solution, and as a result you get a mixture of an active and inactive configuration of LSD at the end of the synthesis. The different isomers are caused by the orientations of the hydrogen atoms that are bonded to carbon 5 and carbon 8. Isomers play an important role in the activity of LSD. This is because the receptors in our bodies require that the molecules binding to it has a specific configuration, otherwise it will not bind properly. In LSD, it is caused by these two hydrogen located on carbon 5 and 8.
The synthesis begins with the initial compound being treated with thionyl chloride, converting it to the acid chloride. Then, the molecule undergoes an intermolecular Friedel-Crafts reaction after the addition of aluminum chloride. In this step, a substituent needs to be added to the alpha carbon to ketone carbonyl, so treating the compound with acid media and then with bromine gives the desired intermediate. Then treating the brominated intermediate with methylamino acetate, ethylene ketol gave the desired alkylated intermediate, which could be hydrolyzed using HCl to deprotect the acetyl and the benzyl group that protected the first nitrogen atom. Next step is the formation of the hetero-ring D, which is achieved by treating the last ketone intermediate with sodium methoxide. The treatment of this compound with sodium borohydride and sodium anhydride, which selectively reduce the ketone group and protect the ring B amine nitrogen. The next step to be performed was the substitution of the alcohol group for a chlorine atom. Treating the alcohol with thionyl chloride and sulfur dioxide gives the intermediate. Then treat the compound with sodium cyanide and anhydrous liquid hydrogen cyanide. Resulting intermediate was treated with methanol to yield the methyl ester. The acetyl-protecting group on the nitrogen of ring B was removed due to the acidic conditions. The last intermediate of the synthetic route was treated with previously heat-deactivated rainy nickel. This is ergonovine, which makes the alkaloid preparation complete. The last step is just the formation of an amide bond between lysergic acid and diethylamine, done under conditions used by Shulgin.
LSD was first synthesized in 1938 by Albert Hofmann, but the psychedelic properties were not discovered until 5 years later. The following is a dramatization of Albert Hofmann's experiences with LSD. April 16, 1943. After working with the ergot fungus, I was forced to interrupt my work in the laboratory in the middle of the afternoon and proceed home, being affected by a remarkable restlessness combined with a slight dizziness.
At home, I lay down and sank into a not unpleasant, intoxicated-like condition characterized by an extremely stimulated imagination. I perceived an uninterrupted stream of fantastic pictures. After some 2 hours, this condition faded away.
In order to investigate the effects of the ergot fungus and to verify that the fungus was the cause of my experience on Friday, I participated in a self-experiment and ingested a small quantity of LSD. By now, it was already clear to me that LSD had been the cause of the remarkable experience of the previous Friday, for the altered perceptions were of the same type as before, only much more intense. I asked my laboratory assistant, who was informed of the self-experiment, to escort me home.
This tree speaks to me. So what happens to your brain when you're on LSD? Imagine your brain is a business with multiple departments. The eye department gathers data and sends it to the sight department. The ear department gathers data and sends it to the hearing department. The nose department gathers data and sends it to the smell department. At the head of all this is an operator. He is in control of making sure that the data goes to the proper place. On the weekends, the operator likes to party, and he shows up to work a little hungover. Unfortunately, in his current state, he stops paying attention to where he sends all of the data, and so the music that the ear is listening to is sent to the sight department, and you begin seeing music.
After 40 years, LSD has been recently FDA approved for a medical trial where the subject of study are patients who suffer from deep anxiety due to serious illnesses. For more information, follow the link.